You can see okay? I think so. Right. So, I think that, yes, this is the last derivative rule, and then after this lesson, next week, we'll go on to integration, which is bigger. So so far we have 3 rules: product rule, quotient rule, and chain rule. And this last one is called implicit derivatives. So let me give you an example. No. This might be the end. I'll use my mouse for the moment. Oh. Right. Let me give you an example. Okay. Right. What I want you to try and do is get the derivative of y squared. I want to see what you think it might be. So y squared. Yeah, you think that it might be 2y, for example. Okay. So let me show you why that is not true. So let's say y equals x squared. Okay, so tell me what y squared equals. You can write this down. Y equals x squared. So what does y equals x squared. So what does y squared equal? Yeah, so write that down. Y squared equals x power 4. Okay, so write that down. Y equals x squared and y squared equals x power 4. Okay? Now, what is the derivative of y squared if it's equal to x power 4? So what's the derivative of x power 4? 4x cubed. Yeah, so write that down then. Derivative of y squared, so dy squared dx equals 4x cubed. You got that? Now, a lot of people at the start thought the derivative of y squared would be 2y. I want you to check your answer. Is your answer the same as 2y? No, it's not, because what would 2y be? 2x squared. And what answer do you have? 4x cubed. Are they the same? No, not the same. So it's not quite as simple as maybe you thought, but again, it's not going to be too difficult. Okay, so let me just, since I can't write for the moment, I'll just type it then. So anyways, back to where I was a second ago. Whoop. Y squared, its derivative is not 2y. So this is what we call implicit derivative. This is when you want the derivative of y, not x. Okay? So I'll show you now. I'll have to write a little bit with my pen, but be strong. Okay, so that's a d. Okay. Derivative of f of y, steady, dy. That's not too bad, is it? Yeah, it's okay. Right. We can use actually the chain rule to help us here with this. I can change this into dy dx, derivative of the y part, the function of y, like y squared, over dy. Now, why is that the same? Well, if you look from the chain rule from last class, you can cancel these. So if I cancel these, what am I left with? df dx, which is this, oh sorry, I meant, that should be an x there, sorry, I'll fix that. Yeah. Which is the same. So in other words, this is actually the rule. If you want to differentiate a function of y, like for example y squared, you differentiate it, you get 2y, but the only thing that's different is you must multiply your answer by dy dx. That's all. So we'll look at the example I gave you a moment ago. I said y equals x squared. So what does y squared equal? We said x4. So what's the derivative of y squared? That's 4x cubed. Yes? Now let's try and use my new rule from today. The new rule says the derivative is the regular derivative multiplied by dy dx. So let's use my new rule then. So new rule for today. Yeah, so the new rule says if you want to differentiate y squared, you do it normally. So what's the derivative of y squared? 2y. But then the price you pay is you multiply by dy dx. So if y equals x squared, what is dy dx? What's the derivative here? 2x. So there's a 2x here. This is 4xy. What does y equal though? X squared. So this is 4x squared, which is 4x cubed. Don't get it? No. Okay. At which line number does it break down? Okay. So you're happy with this? Y equals x squared. Y squared equals x4. Derivative of y squared is 4x cubed. Okay. So my new rule says if I want to differentiate y squared, so that's find derivative of y squared. You differentiate it like normal, so y squared becomes 2y, but the price you pay for differentiating a y term is you multiply by dy dx. So if y equals x squared, what's the derivative of x squared? 2x. So if you were to look at this, this is the derivative of the y squared, and then this is dy dx. So we get 4xy. That's okay? What's y equal to though? X squared. And we get 4x cubed. My point is, you get the same answer using the new rule as what we got previously. Now, this is not what we actually do in the exam. I just wanted to show you that the rule works. If you believe me that the rule works, then you can forget about this. You'll take this approach, yes? Okay, fine. So, if you believe me that the rule works, then you can forget about this, and I'll show you how we do it in the exam. So, for example, if a question asks you for the derivative of y squared, the answer is 2y dy dx, and that's it. Oh dear.
You don't have to substitute?
No, you don't. There we go. What would be the derivative of, let's say, y cubed? What's the derivative of y cubed? 3y squared dy dx. Do you get the idea? So it's like, really, y derivative is the same as an x derivative, except you must multiply by dy dx. Okay?
The dy dx will be the value for x. No, not the value, but like y. The value of the function.
No, it will be a function, not a number. Yeah.
Yeah.
But I'll give you an example. So let's have a look at an example here. So let's say you have something like x squared plus, so actually maybe you want to write this one down. This is our first real example. So example 1 then. So this is the type of question that you would get, in the exam. You're asked to find the derivative here, dy dx. Don't do it just yet. Just write the question down. X squared plus y squared equals 1. You got that? So, one way you could find dy dx is you could rearrange this. Oops, I don't want to write it twice. You could rearrange this and get y squared equals 1 minus x squared. So after a little bit of rearranging, you could end up with something, oops, not that, like that.
You get the rule.
But no, but this is not the way you do it, because this is a much more difficult way to do it. If you use the rule from today, you can do it a lot quicker. So let me show you. If I use today's rule, what's the derivative of x squared? Well, that's just 2x, that's fine. And what's the derivative of y squared? 2y dy dx. dy dx. And what's the derivative of 1? 0. Now you can see that it's very easy to get dy dx from this equation, isn't it? You get dy dx equals minus 2x divided by 2y. So you get minus x divided by y. So this is a lot quicker to do than the other way with the square root. So this rule is very good for these types of problems where the x and the y are mixed together.
So we should find the dy dx. I thought it was to use the dy dx.
Yeah, well, these questions, usually they have you find dy dx as part 1, and then part 2 they have you use it, like what's the maximum or something like this.
Do you have to substitute the value?
Yeah, and
of y?
also they would give you a point xy to substitute
like in
in.
the first equation, like x squared.
And you might have to do that as well, yeah. We'll look at some examples. Question? That's the answer. The question was, what's the derivative? What's dy dx? This is dy dx equals minus x over y. So this is advantage is that it's very quick to do, but there is one disadvantage. Can anybody see a disadvantage?
Two variables.
No, not disadvantage.
Like you have y and x.
The disadvantage is that the answer has x and y in it instead of only x. So they must give you x and y. They can't just give, well, they could, but you need to know x and y here to get the answer. So I could say, what's dy dx at 1, 1? So you put in 1, 1. What answer would you get here? Oh, hang on. Yeah, 1, 1. You would get minus 1, as an example. Okay, try this one for me. Example 2. So again, find dy dx. Let's say x squared plus xy plus y squared equals 1. X squared plus xy plus y squared equals 1. Try this for me before I do it. Did you try it? Did you try it? Maybe. Get an answer? No? Impossible? Let's have a look. It's similar, but there is one difference. Okay, what's the derivative of x squared? 2x. And derivative of xy?
X dy over dx plus y.
Yeah, you need the product rule because you're multiplying x and y. So firstly, derivative of x, that's 1. So 1y plus, and now we keep x, and what's the derivative of y?
dy.
1 dy dx. Plus, what's next? Derivative of y squared?
2y
2y dy dx equals 0. So this is what equation you should have. You should have 2x plus 1y plus 1x dy dx plus 2y dy dx equals 0. Some of you got this, maybe? No? I think the trick was the product rule. Maybe some people didn't see that.
In the example, we have to arrange it?
Yes. So the next part is to find dy dx. So I need to rearrange it. So you shouldn't do this in the exam, but you could do this in your head. You know, you have to bring the 2x and the 1y to the right. Question? Question? Questions are good. Questions? Solved? Okay, fine. So you bring the 2x and the 1y to the right. You get minus 2x minus y. And then we have to divide by the x plus 2y. So when you rearrange it, you should end up with this. I just took this piece and this piece to the right, and then divide by these two pieces. I end up with this. So this is dy dx. Yeah? Okay, so let's make it a little bit more difficult now. Yes?
Can you just exchange this to x plus y squared minus x squared?
Say again? X plus y. Oh, x plus y squared minus xy.
Yeah.
You could do that. I don't know if it makes it easier, but it's allowed. You can do it, yeah. Yeah. Okay. Continue? Yeah? Okay, so let's go back to something simpler for a moment. Example 3. X squared plus y squared equals 1. Or, no, let's make it a little bit bigger. Okay, well, 5. X squared plus y, 25, goodness sake. X squared plus y squared equals 25. So my question is, find dy dx when x equals 3. Okay, try this one for me. You got an answer, Tony? What did you get?
True also.
sounds believable. I think so. Is that the only answer you got? There should be two answers. Okay, let's have a look at this. So, first part derivative, that's okay. We have 2x plus 2y dy dx equals 0. So what does dy dx equal? Well, we did this one earlier. What did we get? Minus x over y. Bring the 2x over and divide by 2y. Now here's a small problem. I only give you the x, but what do we need for this formula? We need the x and the y. So how can you find the y? Yeah, you put the x back in here. What did I tell you the x was? 3. So I'll just put in, substitute x is 3. And you end up with this equation. 3 squared plus y squared equals 25. Can you get the y from this? You can't. You should get two answers for y. Because this becomes y squared equals 25 minus 9. Y squared equals 16. So y equals plus or minus 4. You get two answers. So that means when you go back here, you have two values to put in for y. So we'll put the first value in. What's x? I said x was 3 and y 4. That's the first answer. And then if I put in the second one, I put in 3 for x and y is minus 4. So no surprise, I get nearly the same answer just with a minus.
Why we don't first substitute the x and then find the dy dx? Because I did that.
First you substitute in the x.
Yeah.
No, whenever they give you the value for x and y, you can only substitute that in after the derivative has been found. Yeah. It never works beforehand. Yeah. So your answer is actually plus or minus 3 over 4 for the derivative. Okay, I'll give you another one now. Can I write it down? Next one. This is example 4. Okay. Right, so we'll have x squared minus 2x plus 1 plus y squared minus 2y plus 1 equals 1. X squared minus 2x plus 1 plus y squared minus 2y plus 1 equals 1. Of course you can simplify that if you want. Okay, so my question is, I want you to find the maximum. Find the maximum. Can you see it okay, Remo? I'll read it out to you again. X squared minus 2x plus 1 plus y squared minus 2y plus 1 equals 1. Finished already? You stuck? Did you get the derivative? That might be step 1. Find dy dx. Yeah, so the derivative of 1 would be 0. Yeah. Try English. Who are you chatting to? I guess that's important. Is it? He knows you're in school, right? Yes. Finished? Oh, you were asking him for help. Yes. Come on, guys, give it a try. No. Did you get dy dx? Okay. Maybe I'll do it now. Right, have a look. Look up. Well, if you think you can finish it then. So, I'll do it anyways for those who want to see. Firstly, the derivative. So, what's the derivative of x squared? 2x. Derivative of 2x, 2. Derivative of 1, 0. Derivative of y squared, 2y, dy dx. Derivative of minus 2y, minus 2 dy dx, plus 0 equals 0. So you should have this. What's in common here? 2, isn't it? So let's cancel by 2. X minus 1 plus y dy dx minus 2 dy dx equals 0. Huh? This is okay. Oh, what the heck? Yes, sorry. There now, fixed. That's okay now, isn't it? X minus 1 plus, It's okay? Now we can get dy dx. Dy dx equals 1 minus x over what? Y minus 1. So you should, I was hoping you could at least get to here. Yeah?
Will y always be dy dx?
Just a plain y by itself will always be dy dx, yeah. Continue? Oh please, I love questions. Give me your question. The minus? 1 minus x. Oh, you took the minus out here and wrote x minus 1. No problem. No problem. Did he tell you it was a problem? Don't listen to Tony, okay? It's okay? This okay? Yeah? Now, I asked for the maximum, so what do I need to do next? Make this equal to 0. So I have 1 minus x over y minus 1 equals 0. So I hope you can see what this tells me about the x. X must be 1. Because the only way to make this fraction 0 is if the top is 0. And the only way the top can be 0 is if x equals 1. But how can I find y? I have the x, that's great, but I still need y. Yeah, go back to the original, and then what? Substitute x is 1. So if I substitute x is 1, I'll get this equation. It's the same one except x is 1. 1 squared minus 1 plus 1 plus y squared minus 2y plus 1 equals 1. What type of equation is this?
Quadratic.
It's a quadratic, so that's what it looks like, although I don't like the stinking 1 on the right there, so if I take the 1 over, that's better. So that's my quadratic I want to solve. Do you want to factorize or do you want to use the formula? Whichever you like, I don't care. You can factorize or use the formula. So if you solve this quadratic, you get 2 values for y, 0 or 2. Now the problem is, to know which one is the maximum, you would need to substitute it in. But the situation is we have 2 answers. The first answer, what was our x? 1, wasn't it? 1 and 2, or 1 and 0. Now, you don't need to check which one is the maximum because they won't ask you to do that in the exam because it's now a little bit too difficult. Because if you want to know which is the maximum, what would you need to do next? If you wanted the maximum, second derivative. So it's not impossible. You could calculate the second derivative here. It's not impossible, but they don't usually do that in the exam. It gets too messy because what rule would you need here for second derivative? Quotient rule and also implicit derivatives. So it gets very messy. But if you were to guess which one was the maximum, which one do you think it would be? 1, 2 or 1, 0? Correct, 1, 2. So let me graph this for you. Does anyone know what graph this makes? Does anyone know? It's not on the course, so you don't need to know. I just was wondering if anyone knows it. What do you think, Tony? You think something?
Circle?
It's a circle, Malik, yes. If I graph it, you can see it. Now, it doesn't look like a circle just because of the scale. So where's the maximum on this graph? 1, 2, as we predicted earlier. So you can get questions like this. Here you go. You can get questions like this in the exam, but they probably won't ask you to decide if it's a maximum or a minimum. They've never done that in the past. Okay. Let me give you one more to try. Example 5. Is it example 5? Yeah, okay. Okay, so find the equation of the tangent at the point 5, 12. Yes, that's right. Okay. Try this one for me, please. What you checking, Remo? No calculator? Where's your calculator? And it's all the way over there by the window. Oh, yeah, no. I totally understand. You must save your energy for maths, yeah? So the first step is to calculate the derivative, like normally. The dy dx. Yeah? You got the answer? Okay. Got an answer? Let's have a look at this now. So what's the derivative here? 2x plus 2y dy dx equals 0. So dy dx equals minus x over y. Do you know x and y? You do. What's the x? 5. And what's the y? 12. So, there you go. So that means the slope equals minus 5 over 12. Because remember from semester 1, the derivative is the slope of the tangent. So, how can I find the c now? Substitute in the values. So what's the y? What's the y? 12. The m? Minus 5 over 12. The x? 5. Do you have enough information to find c? Yeah, so let me just do it here. So the c is an ugly 169 over 12. But that's it finished. The answer is y equals minus 5 over 12 x plus 169 over 12. I hope some people got this. It's a little bit of revision from semester 1 when you have to find the tangent line. You remember doing that? What's the other type of line you could find? Tangent and normal. What's the difference with the normal? It's
derivative.
What's the word?
Degree.
Perpendicular. So the slope, for example, here, what would the slope be? It'd be 12 over 5 for the normal. Remember tangent and normal? Yeah? No? You remember some of it? Yeah. There's another example I want to do, but I'll do it a little bit later. What I want to do now is I want you to try these for a few minutes, then we'll do the tutorial, and then there's a couple of examples down the end. Now for the exam, you don't need question 1 for the exam. Question 2 and 3 are section A questions, and 4 to 12 are section B questions. So 2 and 3 are section A, 4 to 12 are section B. I'd like you to try some of these now, okay? For, I don't know, 5 or 10 minutes. Then we'll have a look at, you had some linear regression questions, isn't it? Can I close this?